So yesterday we looked at what can be done with water in order to help control erosion. Well, that's only half the story. What we're going to look at today is what can be done with these sediments as opposed to working with the water in order to help control erosion. Because remember, erosion is the movement of stuff, sediments. So sometimes we can work with those and we can limit the erosion. Now, it comes down to two things. One, don't let water pick up sediments. And two, make water drop the sediment when it has already picked some of them up. Remember that sediments come in different sizes, all the way from boulder, cobble, pebble, sand, silt, and clay. And remember that big stuff doesn't move as easy as small stuff. So consider this situation here. We've got a lot of houses and streets and impervious surfaces up here. This is actually very close to Centennial High School. It's that new neighborhood over there that they built across from the stadium. Well, water runs into the drains up here, and we're trying to get it to the retention pond, which is over here. But notice that drain has to drop a good bit of this, and that water is going to be going really fast. Well, fast water moves stuff more easily, especially when we have a lot of clay in our soil, which is really small and tends to get moved easily. So let's do this. We can't make the water not go down that hill. It's got to go down to that low point. It's got to get going fast. But let's replace the small stuff with big stuff that the water maybe can't move. This is where riprap comes into play. These rocks are used to decrease erosion because they're too big to be moved. Remember, water's going to move stuff, but if the stuff is big enough, the water can't move it. And you can see in this picture here, I got my parking lot over here, and I want water to come off my parking lot, and I want it to come down this channel and wind up in the creek. But moving water down to the creek is going to move a lot of stuff, and I would eventually lose all of my sediments underneath my parking lot caves in. So what you do is you put rocks in place there, and the water can't move the rocks. You have less erosion. You can see it here. Here is a soccer field, baseball fields and such in a park, and you want the water to drain from the soccer field, and you want it to get over here to the creek as fast as possible. You don't want to slow the water down. You want it to get off the field. But fast water is going to move a lot of stuff, so you line the channel with big rocks that the water can't pick up and move. Therefore, you don't have erosion, because remember, erosion is the movement of stuff. Now consider there's a middle school in Carrollton. It's on top of a hill. And when it rains, all that water goes running down this hill, and it's going to try to get to the storm drain down there at the bottom of the hill. That's a really big drop. And the water would move a bunch of stuff. And you can see what they did was they put a bunch of rocks in the path of the water. That way, when the water is going to that storm drain, it's not going to cause erosion because the rocks are too big for the water to move. Same concept here. We want water to get off my parking lot as soon as possible. So I put rocks right here. That way the water can't cause erosion. You use materials that are too big for the water to move. Anytime you use rocks for that purpose, that's riprap. This is also why we can't use drainage ditches in cities where we have a lot of extra runoff, because the stuff would move too easily and we would lose the land underneath our roads. Now, a gabion we introduced yesterday, it is a wire cage filled with rocks. The advantage of a gabion over just regular riprap is that it can be made to be bigger. So it can handle a lot more water running past it and or through it than just a pile of rocks, because that's a lot harder to move than an individual rock. So here we've got a big mound of rocks inside this wire cage near a spillway at a lake in Mississippi where it rains a lot. When they get those summer thunderstorms, man, a lot of water comes rushing through here real fast. That amount of water could actually move some rocks, some pretty big rocks, maybe even boulders. So instead, you have to use a gabion where you have the wire around the rocks that helps keep the rock in place. Now, notice here, this is the same river, and you notice it's got a gabion lining the shore over here, but it doesn't over here. And here's the difference. Right here, notice the water coming off the dam gets going pretty fast because it's falling off the dam. Well, fast water causes more erosion than slow water. So over here, we don't need gabions, we don't need rocks, we don't need riprap because the water is moving too slow to cause much erosion. In this spot right here, though, the water's moving fast. We need something that the water can't move, otherwise we're going to have a lot of erosion problems. So how to prevent erosion if the speed of the water is fast? You put big stuff like rocks, riprap, in the path of the water that it can't move it. So that limits erosion. So now imagine, though, that you can't change or control the amount of the speed of the water. What do we do then? Let's do something to keep water from picking up sediments in the first place. Let's lock the sediments in place so that water can't move it. Sometimes you have to take really extreme measures. You'll see hills that are just covered in fences and they look like they're nailed together. That's what we've got here. These are basically big, huge nails that are driven. You can see them right there, screwed into the hillside to help keep the sediments in place. So when it does rain and the water slides down this hill, it cannot move the sediments. The sediments are basically locked in place, and that's one approach that you can take.
So here we've got a really steep hillside, and we've got a place where they built a parking garage and they cut into the hillside to do it. Well, that made the land extra steep. And we're in Georgia, it rains a lot, so you're going to have erosion problems. And we want all of that land up there to stay up there and not collapse into my parking garage. Well, here's the extreme measure that they had to take in order to hold the hill in place. They built that retaining wall, but the wall wasn't strong enough. So what they did was they basically put all those little knobs into the side of the wall. Those are basically nails. Those are long metal supports that go into the hill, and it helps hold that hill in place. What that is called is a landslide anchor. A landslide anchor is basically a nail that you drive into a hillside to help hold the hill in place. And it has to be done someplace where the erosion is going to be really extreme because the land is really steep and there wasn't many other options that you could use.
So this gives you an idea what a landslide anchor looks like. It's basically just a nail that keeps the ground in place. And think about that. You nail something together, it stays together. So the first strategy is hold the sediments in place so the water can't move them. We lock down the sediments where they can't move. There is actually one way that works far better than most any other to hold on to sediments, and that's use plants. Plants do a good job of holding on to the soil. Their roots are in the soil. Plants hold on to soil because they need the soil to grow. If you ever try to pull a plant out of the ground, you know it's hard because they're just locked into the soil. If you do pull a plant out of the ground, you know a bunch of dirt comes with it. The roots of plants hold on to the soil very tightly. If we're trying to keep the soil or these sediments from moving, that's a great option. The plants are going to keep the sediments from being picked up and moved. In our area, the most common plant that we use to control erosion are pine trees. We see these all over the place. The pine trees that you see growing around here, like here out in front of the track on Scott Road here on our campus, they were not planted there by accident. They were planted there on that hill, and you notice it's a hill, and it's a place in Georgia where it's going to rain a lot. They planted those trees there to help hold on to the soil so that we wouldn't have erosion problems. And there's some distinct advantages to pine trees. Here's Centennial High School. This is a picture in 1996 before the school was completed, the summer before the school opened. And you'll notice this hill over here by the bus ramp. And you'll notice what's missing. There's no trees there because there weren't any when the school opened. Same thing on this side of the bus ramp hill before the bus lane. Now, if you go out there, you should recognize, hey, the whole thing is covered with pine trees. And it's covered with pine trees on purpose because those pine trees were planted there to help hold on to the soil. Otherwise, we'd have a lot of erosion and my sediments would wind up down here in the parking lot. So there's 4 huge advantages to pine trees in Georgia. 1, they grow fast and they grow real easy. You throw pine trees out there, think about all the pine trees you see on Centennial's campus. They've only been here, 20, 25 years, and they're all over the place. Second big advantage, they got good root systems. They stick down in the soil deep enough to lock in the soil. A third big advantage is they can be planted very close together. And think about that. If you've ever nailed something together, the more nails you use and the closer the nails are together, the more it's going to hold something together. Well, that's what pine trees do. They have good deep roots that go into the soil, and you have a bunch of pine trees really close to one another that locks in the soil. The other advantage is they cover the ground with pine straw. And we saw yesterday that pine straw makes runoff water slow down and increases infiltration, which is going to lessen erosion. Now, hardwood trees like oak trees, they don't do nearly as good a job as pine trees, because with oak trees, notice the roots aren't as deep. The roots are actually fairly shallow and they're wide, so that when the ground moves, the tree is able to move with it. Pine trees don't move when the ground moves because they go in too deep and there's too many of them close together. Oak trees and maple trees and trees like this, you can see they don't do nearly as good a job for erosion control. Now, there's some limitations to using trees. We can't plant them right next to roads in a lot of cases, or we can't put them right next to our house. You know, that's dangerous. Windstorm comes up, then maybe the tree breaks off or a branch breaks off, hits your house, hits your car. So you can't use pine trees every single place you need to control erosion, but there's some other options. You also can't use pine trees beside highways, because if you're going along the highway at 65 miles an hour and you run off the road, you blow a tire, you don't want to hit a tree. That's very, very dangerous. So if you'll notice things like Georgia 400 and your faster moving highways, you're not going to have trees planted on those slopes, because it just makes it too dangerous. If a car were to go off the road and hit a tree, it's going to kill somebody. So what do? You use other types of plants, because all plants hold onto the soil. This is the exit, I think, off of Windward Parkway on Georgia 400. And when the exit was redesigned and they did some construction and they needed to cover the ground because they want the ground to stay in place, they put all of those plants there. And each little plant holds its own amount of soil, and collectively it's going to lessen erosion on my hillside. Now, one thing about when you plant plants in big groups like that, you don't plant them in neat little rows like you would in the farm, because what you do is you make the water wiggle its way through the plants. And that causes water to slow down, and slower water causes less erosion than faster water. Now, here's a typical plant that you see a lot of in our area. This is called juniper. This is very commonly used in our area to control erosion. This right here is a house that I had showed you previously where the guy was having some erosion problems. His deck was starting to come off his house. His patio was starting to crack. So he went in and he planted this juniper to try to hold the sediments in place so the hill doesn't move and consequently his house doesn't move. Now let's talk about some advantages and disadvantages to juniper, because it's used a lot in our area. Advantages, man, the stuff is thick. I mean, it really locks down the soil. If you've ever seen these plants, they grow very kind of bushy and thick, and when water gets in there, man, it really just kind of hangs out in there and will soak into the ground. Now, the disadvantage of juniper is it grows very slow. And if you have a house, you may be, especially new construction, you don't want to wait a couple years maybe for the juniper to grow thick enough where it helps fight the erosion. Now, ivy. English ivy, a couple other names, but you see this is kind of like a little viney little plant that kind of grows around in our area. It's very commonly used to control erosion. That's one of the reasons why it was planted here. That's the primary reason why it was planted here. Someplace where you don't want to have grass and you're worried about the land washing away, you throw this ivy out there and it grows super thick. If you've ever had to walk through this stuff, you know it's just really, really tight and locked into the ground. So it's a good choice, but it has some distinct disadvantages. Its first advantage is it's very thick and it grows easy. Disadvantage is it doesn't really grow in pure sunlight, so you can only use it places where it's kind of shady. It's also very hard to manage because it will grow out of control and climb the trees in your yard. It'll climb your fence. It'll climb anything. And with trees, it'll kill trees. And so that's not a great situation for you, but it does help to control erosion. Now, weeping love grass, and weeping love grass is just one example of what they call a bunch grass, which is what this is. This big clump of kind of brownish, sometimes greenish looking grass that you see on hillsides. We have some right across the street in the Kohl's parking lot. We have some here on our campus. You tend to use these along roadsides where you can't plant trees. Now, this stuff's not pretty, but it grows thick and it grows really easy here in Georgia, and it does a great job of locking the soil in place. So it doesn't matter how much water comes down the hill, that love grass is going to hold on to the soil and it's not going to be able to be moved. Now, nobody's going to plant this in their yard because you can see it's kind of ugly looking. It's not very pretty, but beside highways where aesthetics or how it looks isn't really important, this does a great job.
So here I am on Riverside Drive here in Roswell. Riverside Drive is a very old road. It's been here for a very long time. We've got the river right there, and we've got this very steep hillside back here behind us. And you know what happens when it rains? Water comes down that really steep hillside. It's trying to go over there to the river. And as it comes down that hill, it's going to wash dirt and rock and soil and cover up my road. Well, I want this road to be clear of debris. So, in the 1930s, here's what was commonly done around the South to fight that erosion. They would cover the hillsides with this plant back there. That's called kudzu. It was a vine that was brought in from Japan in about the 1930s, and it really likes growing here in the South. It grows very, very thick and really locks the soil down. And I guarantee you that guy up there in that house likes the fact that the kudzu is here on the road because it keeps the hill in place, which means his house is not going to slide down the hill when it rains.
So here's another situation in Roswell where they put some kudzu out, and this is, like I said, almost 100 years ago, and the kudzu did a great job of locking down the soil. But we got a problem with kudzu. Is that kudzu grows out of control. It grows so fast you can't manage it. And you can see it has covered up this tree. It's killed that tree, or going to kill that tree. That's a problem. So now it becomes, what do we do to control the kudzu? Yeah, it's helping with the erosion, but now it's gone a little crazy.
So let's look at one of the problems that we have when we use kudzu and the English ivy and some of these other kind of imported plants that we use to help control erosion. Well, you see down there behind me, we've got a gully, we've got a stream running through there. And this is right in the middle of a neighborhood. I'm in a park in the middle of a neighborhood, and it rains a lot. Extra runoff is going to take away my soil, and I don't want my neighborhood park and my streets to be washed away. So years and years ago, somebody planted English ivy and kudzu. It did its job. It really held the soil in place. But here's the downside of doing that. You'll notice the English ivy is growing all over these trees, and it's going to suffocate these trees, and it's going to kill them. The English ivy and kudzu will grow so well that it will grow into the streets faster than you can control it, because you can't cut this stuff fast enough, and there is no chemical spray that you can put on it that will keep it from growing. So this is a real problem around the South, where we've brought in this kudzu and English ivy to control erosion. It did its job, but now we've got another problem, and that is, how do we control it? Well, I'm going to show you one of the most environmentally friendly methods and one of the most cheapest and cost-effective best ways to help control these plants. Here is our environmentally sound method of controlling kudzu and English ivy and some other invasive plants that grow out of control. We use goats. These goats here were rented by the city of Doraville and were put in this park to just eat up the kudzu, because the goats will eat the kudzu all the way down to their bulbs, which grow underground. It's cheap, it's easy, all you gotta do is put the goats out there, and it doesn't harm the environment. And if and when the kudzu grows back thick enough again, you just bring the goats back. You can see back over that hill behind me, that was entirely covered in kudzu. But the goats now have stripped the hill bare, and the kudzu's not a problem anymore.
Now, we know plants do a great job of holding onto the soil, especially trees. It's a good idea to leave trees and plants alongside rivers, because rivers are where the water is moving and where you're going to have water that's going to pick up sediments and cause erosion. So because of this, most rivers are not cleared all the way to their bank. You got to leave some trees along the river bank, otherwise you're going to have erosion going out of control. Matter of fact, it's the law most places. You can't cut down trees within a certain distance of the river. Those houses down on Riverside that are right on the river, they can't cut a tree in their backyard without getting permission first, because you have to leave it there to help hold on to the soil. You can see this. These are called buffer zones or riparian buffers. They are rows of trees left alongside the river to help hold the riverbank in place and lessen erosion. You'll notice here, there's the cleared area over here. Somebody cleared out all that area, but they left the trees right alongside the river, because those trees are needed as a buffer strip to help hold on to the soil or the sediments so you have less erosion. You can see it from the air. You can see these little streams going through there, especially this one over here. I like this because it's in the winter time, so everything else is white covered in snow, but you can see how the trees are left right beside the river, and that's to help hold on to the soil, cause less erosion. In Georgia, we actually have a law that you must have a 50-foot undisturbed buffer beside streams that have trout in them, because trout can't live in cloudy water. The water gets cloudy from too much erosion, sediments being in the water. So the mountain streams, the mountain rivers, you can't cut down a tree within 50 feet of the river, because those trees are needed to hold on to the sediments and not have so much erosion and sediments piling up in the river. So, guys, erosion is going to happen, and you know it's natural. Water is going to pick up some sediments, but we can control what happens to those sediments when the water is moving it. Consider the situation here. Before they finish building this neighborhood, or whatever it is they're building, it's going to rain, and the water's going to run downhill, and it's going to pick up some sediment. The question is, where does it take it, and where can I have it dropped where it won't cause problems? If too much sediment goes into my storm drain and then into my river fills up with sediments and I got to dig it out. That's a process called dredging. Dredging is just removing unwanted sediments that have piled up inside of a watercourse, like a river or a stream. And you can see it's not an easy process. It's expensive. You got to pay somebody to go out there and do it with all this equipment. And while you're waiting to do that, that means that if there's more sediment in the river, it can hold less water. You can get a flood. This is bad news. I don't want sediments going into my storm drains, because they'll clog my storm drains and then cause me to have floods. So what can we do to keep these sediments from going into my storm drain? This is a really bad situation. Look at all that dirt that's going into my storm drain. It's going to clog up and I'm going to get a flood. Here's what we do. And you've seen these around. These are called a silt fence. It's a fabric barrier. It's like a screen or a fence that makes water slow down. Now, water can go through it, but the water has to slow down so that it drops its sediments first. And the sediments don't wind up in the storm drain. Just the water comes through. You can see in this situation here, this is a new construction and water was running down the hill. It was picking up dirt. Notice the parking lot over here is fairly clean because the silt fence made the water stop and slow down. And as the water came through the silt fence, it was going so slow it couldn't hold or move sediments anymore, so it dropped all the sediments back there. And that's okay. I want the sediments back here and not going this way into my storm drain or into my river. Here's some poorly used or poorly designed silt fences. You can see there's silt fences in both cases, but notice all the dirt, all the sediment that's coming through them. If this were in Roswell and some builder has a silt fence up like that, he's probably getting a ticket because they ride around Roswell looking for infractions like this or improper use of erosion control devices, because that means all of these sediments here are going into my storm drain, which may be going to my river, which I don't want the extra sediments clogging the Chattahoochee. This is called a rock bag. A rock bag is something you can put in the place of water. So water's picking up dirt and it's moving it somewhere. Well, when the water hits the rock bag, it has to slow down to get through there. Well, when it slows down, it can't hold the sediments anymore, and so it drops the dirt back here. And you can see it in this picture. There's my rock bag, and you can see my sediments. The water was picking up some dirt, and it came here. Well, it hit the rock bag, and the water had to slow down to come through the rock bag. And because it slowed down, it had to drop the sediments it was carrying back there. A mulch bag is the same thing, except it's not filled with rocks, it's filled with mulch or hay. You typically see these put over storm drains during construction, because you can pick them up and you can set them down and then take them away. And you'll notice, look at all of those sediments that otherwise would have gone into the storm drain and clogged it. Now we put hay in the ground, especially with new construction, because remember that the hay makes water go slower. And therefore the slower water can't pick up and move sediments as easy, so it helps keep the sediments in place. Now, an advantage of hay over some of these other things is that hay is natural and it will just decompose. A straw wattle works the same way. Here I've got water coming down the hill, and it's going to be picking up sediments. This is my storm drain. I do not want sediments there because I don't want sediments to go into the storm drain. So the water comes down the hill, picks up some dirt, but then gets to the straw wattle and has to slowly work its way through. Well, the water can come through, but the sediments are left behind, and it keeps sediments from my storm drains. I'm causing the water to drop the sediments here as opposed to drop them in my storm drain. An erosion blanket is like a blanket. It's a roll that you roll out, and it's got straw in it, and typically it then has grass seed in it, where it will then grow and help hold onto the soil. And look at the difference here. Look at all that erosion there. No erosion there, because the erosion blanket was holding the sediments in place. Winter rye grass. You'll see this around in our area, typically with new construction. And this is just some new construction off the side of the road up here on Holcomb Ridge Road, where they put in a new sidewalk. They put in this bright green growing grass. And that is not meant to be somebody's pretty front yard. That winter ryegrass is put there just to hold on to the soil before the regular plants can grow, because it's going to rain and water's going to move downhill. And if it does move downhill, it's going to take sediments over here to this stream, which goes right to the Chattahoochee River, which I don't want extra sediments in the Chattahoochee River. So just by planting that grass, it will help hold the sediments in place. Now, summertime comes and that winter ryegrass will die. But by summer, then the regular grass has started to grow in. So what do we do if water does pick up sediments? Where are they going? And what do we do about them? Remember this concept of deposition where water is being dropped. Well, that can be just as bad as sediments being removed. So sometimes we got to control where the sediments are dropped rather than whether or not they get picked up. Well, how can we make deposition occur? Well, if water slows down, it's going to drop its sediments. The question is, where is it okay for sediments to be dropped? We don't want sediments dropped here. I don't want sediments, clogging up my streets and my sidewalk. I certainly don't want sediments dropped here in this flooded park, or I don't want them dropped in the Chattahoochee River because then my river fills up with dirt. This is not a good situation. Let's have the sediments drop someplace else. Retention ponds. Okay, retention ponds, we can drop some sediments in the retention ponds, and you can see in the picture in the upper right, you can see all of that dirt, all those sediments that were floating in the retention pond. They're going to settle to the bottom. So that's okay. The problem is, what happens over time when too much dirt winds up in the retention pond? If it fills up with dirt, then it's not going to hold any water. And I got to come and do this. If a retention pond fills up with too much dirt, I got to dig it out so that it will hold the water that I need it to. So it's not horrible for dirt to wind up in a retention pond, but it's not the best situation. Wetlands, again. Now, wetlands are okay because remember, wetlands are big, wide areas. You can spread a lot of dirt out over a wetland, and then you can still pile water on top. And the sediments are actually necessary for a wetland because the plants need that dirt and they need the nutrients from the sediments to grow. So this is a good situation for us in the Big Creek Greenway. When it floods, all of those plants and trees and such over there, they get some new soil and they get some new nutrients that the plants need in order to grow well. So dropping sediments in a wetland is a really good choice. Another reason why we need to leave wetlands in place, because that's a place where any extra sediments can be dropped and it doesn't cause us problems.
So here we've got a problem. We've got a pretty steep hill with a lot of really big and loose rocks up there. And then right over here, we've got a highway. See the problem? If it rains really hard or we get a little bit of an earthquake, these rocks are going to come rolling down this hill and they're going to come across this highway and hit the cars that might be traveling or just block the road. So here's what we do. This was built here. This is a rock slide fence. Now it doesn't look like much. It looks like a regular chain link fence, but it has this very, very thick wire here at the top. It's a lot stronger than a chain link fence that you would have in your backyard. You can see what it does. The rocks roll down the hill and it's just strong enough and it flexes and gives just enough that the rocks get caught up in the fence before they roll across the road. We can see all up and down this fence the number of times that this fence has stopped the rocks from rolling into the highway. Once again, this is a rock slide fence. The advantage to building them like this is it's pretty cheap, and if it gets destroyed like it is right here, it's not really expensive to come back and put up a new one of these, and they probably will have to because those rocks are still up there. And some of those rocks are going to continue to come down, and eventually this fence is going to snap. But it's not too big a deal to go back and replace it. Once again, a rock slide fence. You can see why it's needed and how it works.
So here, a rock slide fence in a definition is just a barrier that's meant to stop the motion of sediments in a rock slide. It's not like a regular fence. You can see these all extra thick and reinforced, but you get how it works.
So here I am on a road on the side of a mountain in East Iceland. Iceland is a place that gets a lot of rain, and you can see that the land is very, very steep. You can also see that there aren't any plants on the side of this mountain, which means they're probably going to have erosion problems. Well, we don't want that mountain coming down and wrecking or covering up our road. So here in Iceland, they have to do some stuff to help prevent rock slides. One of the things they do is they stack up these rocks and put them inside this wire cage. Now this is a lot cheaper and a lot easier than building some kind of wall. All you gotta do is pile up the rocks and tie a cage around them. And the nice thing about these are that they are a little bit more flexible. They can bend, so when they get hit by a rock that might fall down from this hill, they're not necessarily gonna break and fall over in one piece. They're gonna absorb some of the impact. Now, even this sometimes isn't enough. We can see right here, a whole section of this barrier has been knocked over. They had a rock slide. You can actually see the running water up there, and you can see where the rock came down. If we look down here, we can look at the size of some of the rocks, and odds are they came here and they hit this barrier and they kind of destroyed it. But what it didn't destroy was the entire road. So this barrier acted to soften the blow and absorb some of the energy so that your road wasn't taken out by every little rock slide. Here's another example, just a little bit further down the road. You can see the big rocks that came down. Some of these even wound up on top of the cage, but this cage did its job and it kept the rocks from rolling out into the road and destroying the road. Sometimes these rock-filled cages might not even be enough, and you got to do something a little bit bigger, a little bit stronger to stop a potential rock slide. And that's what's the case here. Just down the road, you can see that these are big, huge steel I-beam girders just put straight into the ground. This must be a section of the road where landslides are a little more common, the mountain's a little bit taller, so the rocks get going a little bit faster, so you have to have something a little bit taller and a little bit sturdier to stop the rock slides before they take out your road. So here I've got a slope that I created artificially. I made a little hill and we built the school up there on top. Now I want this slope to stay in place. I don't want it to move. So there are things that we can do to help hold a slope in place. We can plant some trees, we can make sure there's some grass on there, we can make sure the water drains. But sometimes there's a limit as to what you can do. Sometimes the hill is just too steep, like we see in this case here, and you have to do something like this. Here's a case where no matter what you did, no matter how many trees you planted or silt fences or anything you did, this hill would have just been too steep. And over time, our hill would have eroded and wound up down here, taking my building with it. So in an extreme case, there's not much you can do except build what's called a retaining wall. And that's what this is. A retaining wall does exactly what it says it does. It retains the sediments, it retains the dirt on the hill and allows to hold my hill up. So once again, in a case where the land is too steep and nothing else works, you build what's called a retaining wall, which will hold the sediments in place.
So, final summary. You can control erosion by doing one of two things. You either control the speed and the amount of water, or you control what water picks up and drops.